This SOS video is on graphing. So our main concept is that a linear function can be graphed using a table of values. The vocabulary you need to know is that the coefficient is the sign and number in front of a variable. When I say sign, I'm talking about negative or positive. And if I'm going to plot something, that means I am graphing one point. A linear function has a graph that is a straight line. That's how we recognize it on a graph. We can graph it by setting up a table of inputs and outputs called a table of values. Sometimes you'll see it written for short TOV, table of values. To create a table of values, we're going to look at the coefficient of x. So if the coefficient of x is an integer, we're going to use x values of -2, -1, 0, 1, and 2. Because when we use those values, our y value will also be an integer. But if the coefficient is a fraction of x, then we need to use multiples of the denominator. So if the denominator is 3, the multiples I use would be -6, -3, 0, 3, and 6. When we graph a line, what we're going to do is we're going to plot the points onto the graph. So this should be on the graph. We'll connect them. We're going to extend the line and put arrows in each end, because even though we're just plotting a certain number of points, that line will go on forever. There's an infinite amount of points that will be on the line. And finally, we'll write the equation on the line. So let's get started. Our first equation is y equals -x minus 4. And when we look at the coefficient of x, we see the sign negative. We don't see a number, which means that we know the coefficient is a -1. If you do not see a number in front of x, it's going to be a 1. So coefficient is -1. And I look and I say, well, that's an integer, so I'm going to use x values of -2, -1, 0, 1, and 2. And I'll write this in my table. Now I have to find out how to get the y values, how to get the output. Well, I know my equation is y equals -x minus 4. So what I'm going to do is take that x value and replace this variable x with that value. So the opposite of -2 minus 4, the opposite of -2 is a +2, and a +2 and a -4 is a -2. So when x is -2, the y value is also -2. Well, let's try it when x is -1. I'm going to substitute -1 in place of x and write the rest of the equation. The opposite of a -1 is a +1, and a +1 and a -4 is a -3. So when x is -1, the y value will be -3. Well, let's put 0 in for x. The opposite of 0 is 0, and we subtract 4, it's -4. So when x is 0, the y value is -4. Well, what happens when x is 1? Let's substitute that in. The opposite of 1 minus 4, well, the opposite of 1 is a -1, and a -1 and a -4 is a -5. So when x is -1, the y value is -5. Let's try it when x is 2. So I'm going to substitute 2 in for x in my equation. The opposite of 2 is a -2, and -2 minus 4 is a -6. So when x is -2, my y value is -6. I could go on forever like this, but right now we have enough points that we can graph them on this coordinate plane. When I'm ready to graph, the very first thing I'm going to do is label my axes. So my y-axis, the long tail, is my vertical axis, and my horizontal axis is x. I always start at the origin to plot a point, and -2 means I go 2 to the left, and a -2 for the y value, I go down to put a point. Start at the origin again, -1, I go to the left 1, and a -3 for y, I go down 3 boxes. Start at the origin again, 0 for x means I don't go right or left, and -4 for y means I go down 4 boxes. Start at the origin, and when, I'm sorry, this is a positive 1. I did not write that correctly. When x is a positive 1, we go 1 to the right, and -5 for y means we go down 5 boxes. And finally, when x is a positive 2, so I go 2 to the right, I'm going to go down 6 for the y. Now I see that all those points I plotted are in a straight line. So you take your straight edge, and you're going to not only connect those dots, you're going to extend the line all the way through. We put arrows at the end to show that this goes on forever, and we write the equation on the line. You could put it at the top of it, you could put it at the bottom, you could even write it on the side of the line. Just make sure the equation is next to the line that is graphed. Okay, so now let's take a look at this next one. Y equals -1/2 x plus 1. Well, I know my coefficient is a -1/2, and since that is a fraction, we're going to use multiples of the denominator. So this is my x column. This is where I'm going to write my equation. This is my y column, my outputs, and this is where I write my ordered pair xy. Since my coefficient of x is a fraction, I'm going to use multiples of this denominator, and I'll start with some negative. So -4, -2, 0, 2, 4, 6. The reason why I'm using multiples of the denominator is that when I multiply this coefficient by the x value, I want to end up with an integer value. That makes it much easier to graph. So now let's put them in our equation. We have y equals -1/2 times the value of x is -4 plus 1. Well, negative times negative is a positive, and 1/2 of 4 is 2. 2 plus 1 is 3. So when x is -4, y is 3. Let's try it when x is -2. So -1/2 times -2 plus 1 is my equation. -1/2 times a -2 is a positive 1, and 1 plus 1 is 2. So when x is -2, my y value is 2. Let's try it when x is 0. -1/2 times 0 is 0, plus 1 is 1. So when x is 0, y is 1. How about when x is 2? -1/2 times a positive 2 is a -1, and -1 plus 1 is 0. So when x is 2, the y value is 0. Let's see when x is 4. -1/2 times the value of x, 4, plus 1. -1/2 times a positive 4 is a -2, and -2 plus 1 is a -1. So when x is 4, the y value is -1. And finally, let's see what happens when x is 6. So -1/2 times 6 plus 1. -1/2 times a positive 6 is a -3, and a -3 plus 1 is a -2. So when x is 6, my y value is -2. Now here's the great thing. We can check this with our calculator. So go to your calculator, turn it on, and we're going to go to y equals. I'm going to clear anything that's there. And we're going to type in our equation -1/2 x plus 1. So I type a negative. To get the fraction alpha y equals, I want to have numerator over denominator, so I press enter. And now I type 1, move your arrow down, 2, move your arrow to the right. And now to get the x value, I go next to alpha. I don't press alpha, just go next to it. And I press the button that's right next to alpha, x. And then I finish the rest of this equation plus 1. So if I want to make sure my table of values is accurate, I'm going to look for where it says table right above. It's a little bit faint on my video, but you can see it on your calculator. It says table in blue. So to get that command, I need to press my second key, blue, and graph. And now I have my table. So let's move our arrow up to where we first see -4, and we make sure that the y value is 3, which is true. All right, let's go down to -2 on my table, and we'll go to the y value, and that's also 2. And this way I can check to make sure that each of the values on my table of values matches. So I know my answer is correct. Now what's interesting, if I press graph, it's going to show me what my graph is going to look like. So let's put that to the side and actually graph our points on the coordinate plane, and let's make sure it matches the picture you got in your calculator. So I'm ready to graph. I'm going to label this y. I'm going to label this x. And I start at the origin when x is -4, 4 to the left. When y is 3, 3 up, and put a dot. Start at the origin again when x is -2, 2 to the left, and y is a +2, 2 up. Start at the origin again when x is 0, I don't move left or right, and the y is 1, so I move up 1. Start at the origin when x is 2, I move 2 to the right. When y is 0, I don't move up or down, so I just stay there. Start at the origin again. When x is 4, I go 4 to the right. And when y is -1, I go 1 down. And then finally, 6, -2. 6 to the right and 2 down. I notice that they make a straight line, which is what they should. So I'm going to connect that with my straight edge or ruler. I'm going to extend the line, make sure it goes all the way across the coordinate plane. I put arrows at the end, and I write the equation somewhere on the line. And you have just graphed a linear function. Our very last concept is that if a point lies on a graph, when you substitute the point into the linear equation, it will make the equation true. So here's our example. Determine if this point -2, 9 is part of the graph of the function y equals 3x plus 15. So I know in an ordered pair, the first number I see is x, and the second number I see is y. So what I'm going to do is replace that in this equation and say y is 9 and x would be -2. And now let's see if this is true. Is 9 equal to, well, 3 times -2 is -6 plus 15. Is 9 equal to, and -6 plus 15 is 9. So if you have the same exact number on the left that you do on the right, that means this equation is true. And since when I substituted that point in the equation and it made it true, the point -2, 9 is part of the function y equals 3x plus 15 because it made the function true. This is another SOS video.